Hello everyone, this is Mr. Molo for this lesson on reviewing commutative, associative, and distributive property. We might get into some combining like terms depending on how much time we have, or we might save that for another video. So like I said, we're going to at least go over the three properties in this video: commutative, associative, and distributive. Okay, so commutative, the best way I remember commutative is it sounds like the word commute. Okay, and it kind of almost spells it. So when we commute, that means we're going back and forth. Okay, you commute from your house to school, and then you go backwards from school to your house. So it's really the same problem, but it's just written backwards. So you could see in this first example, 3 plus 5 is the same as 5 plus 3. 4 times 3 is the same as 3 times 4. And you'll notice this is only true with adding and multiplying. 3 plus 5 is 8, 5 plus 3 is 8. But if I write it the other way and do 3 minus 5, and 5 minus 3, well then that doesn't work because 3 minus 5 is negative 2 and 5 minus 3 is positive 2. So you'll see it doesn't work with all properties. It works with addition, 3 plus 5, 5 plus 3, and it works with multiplication. 4 times 3 is 12, 3 times 4 is 12. It doesn't work with division. So if I did, 4 divided by 2 and 2 divided by 4, well 4 divided by 2 is 2. 2 divided by 4 is a half. So again, they're not the same. So commutative property only works when you add or multiply in the problem. And then if you did it algebraically, it's the same as saying a plus b is the same as b plus a, or a times b is the same as b times a. So it has to be the same numbers, just written backwards. The other property that we use is associative. And there we kind of see the word associate. So it's kind of changing who you associate with. So it's kind of like I always give the example, let's say you and your mom and your dad are going to the movies. Okay, well, let's say you sit next to your mom. Well, does it matter if you sit in the middle and then your mom sits on the end? Nope, it's still the same outcome. It's still you, your mom, and your dad at the movies. Well, what happens if you sit on the end and then your dad sits in the middle? Okay, so no matter what, it's still the same outcome. You, your mom, and your dad are at the movies. It's just who you're associating with. So you can kind of flip the order around to kind of change things on who you're sitting next to or who you're by. So it's kind of the same thing here. So 6 plus 8 plus 2, and you'll see our parentheses around the 8 plus 2, which means I would add those first. So 8 plus 2, so if I do it that way, 8 plus 2 is 10, and 10 plus 6 is 16. Or, in this example down here, it says 6 plus 8 plus 2. So then the order of operations changes because we're doing these parentheses first now, but we really end up with the same outcome. 6 plus 4 is 14, and 14 plus 2 is still 16. So no matter what, we get 16 as our final answer. We didn't really change anything except for the order of how we added it. There's still a 6, there's still an 8, there's still a 2, but in the first example, I did the 8 and the 2 first, and the 6 last, and then the second example, I did the 6 and the 8 first, and the 2 last, but the outcome's still the same. And then again, we see it works with adding, and if I were to throw a subtracting problem out there, it would not work with subtracting. Okay, it also works with multiplying. So if I do a multiplying problem, 7 times 4 times 5, so here I'm doing 4 times 5 first, which is 20. 20 times 7, let's write it out here. So 4 times 5, so that's the same as 7 times 20, which is 140. Or I could do 7 times 4 first, times 5. So 7 times 4 is 28. 28 times 5, I don't know, but I'm going to assume since it's going to be the same as that problem, I'm going to go with it's 140. Okay, you can also see that, math might be easier depending on which way you do it. Like here with the adding problem, I would definitely do 8 and 2 first because that gives me a nice number like 10. And then add 6 versus 6 plus 8 is 14. A little more confusing. And then especially in red here with the multiplying problem, it's way easier to multiply 4 times 5 first and then times 7 because 7 times 2 is 14. So 7 times 20 is 140. I think most of us could have done that in our head versus 28 times 5. I'd probably have to stop and think about it for a second. I could do it in my head, but it's going to be a little more complicated. So again, associative property doesn't change the outcome. You're still going to get the same answer, 140, 140, 16, 16. It just changes what comes first. And you'll see the big hint for associative property is it has these parentheses around it. So there's usually parentheses with associative property. And then you'll see algebraically it's the same thing. So A plus B plus C. So in the first example, they're adding B plus C first. Second example, they're adding A plus B first. Again, doesn't matter because you're adding them. They'll all get to be the same answer. And then kind of the same thing with multiplying here in blue. A times B times C. Well, in that first example, they're multiplying B times C first because it has the parentheses. In the second example, they're multiplying A times B first because it has the parentheses. All right. So here, when we're talking about terms, so terms are the part of the expression we can add or subtract. Like terms, need to have pretty much two rules. They need to have the same variable, and those variables need to have the same power. So this is x to the first power. So we can add x and y and z. We can't add a and b because they have a different exponent. I'm sorry, a different variable. A and b are different. But then we also could not add, if we have something like x to the third and x squared. Because yes, they're both x's, but this is to the third power and this is to the second power. So we can't do that. So really all we care about when we're looking at like terms is do they have the same variable, same letter, and then is that letter to the same power? So in this case, to the first power. Okay, and then pretty much we just add the coefficients. So the number in front, and remember if you don't see a number in front, that means that's a 1. Okay, so this is what I was talking about where you kind of could do some math to make your life easier. I talk about this, especially when we're doing solving for x and stuff. I'll say a lot that, algebra isn't hard. It's the adding, subtracting, multiplying, dividing that's hard. So, but just by taking a couple seconds, you can kind of look ahead and see, what would be the easiest way to do a problem like this. So here I have 45 plus 16 plus 55 plus 4. You could just add it straight across, 45 plus 16 plus 55 plus 4. But that might require a calculator or might have some places where we mess up. If we kind of look at the last digit, we can kind of see which numbers go together nicely. We can do this probably in our heads then. So here I have 45 and 55. So they both end in a 5. And I know 45 plus 55 is 100. And then I have a 16 and a 4. And I know 16 plus 4 is 20. So I have 120 there. Kind of the same thing here. So 410 plus 58 plus 90 plus 2. So I know 410 plus 90 is 500. And then I know 58 plus 2 is 60. So I end up with 560. If I were to try and add this all up in my head, 410 plus 58, and then take that, and then plus 90, and then take that, and then plus 2, probably a little more complicated. The same thing goes for multiplying, especially on this problem. So here I have 1/3 times 5 times 33. So if you try to do a third times 5, we're just going to get some messy fraction here. That's not going to be nice. If you do 5 times 33, we're going to get a pretty big number, and that's going to be hard to multiply by a third. But it's kind of makes this problem a little easier if we multiply a third of 33. So if we multiply a third of 33, I know that that's 11. And I'm still left with that 5. So 11 times 5 is 55. So just by rearranging how we kind of think and how we look at these numbers can make the problem a lot easier for us. All right, and then in this last example, I have 15 and 1/3 plus 4 plus 1 2/3. So again, kind of the same thing. I wouldn't add the 15 and the third plus the 4 right away. I'd maybe add our fractions right away. So I have 15 and 1/3 plus 2/3. So 15 and 1 makes 16. And I know 1/3 and 2/3 makes a 1 whole. So really I end up with 17 plus 4. So 17 plus 4 is 21 then. So again, just by kind of stopping and thinking for a second before you actually start doing the math, will probably help you with your homework there. Okay, and then the last property we're going to talk about is distributive property. So you can multiply each number as a sum or multiply them and then add. So kind of the same thing here. So I could do 8 times 33. Again, that's going to be kind of hard to do in our heads and stuff. So I could break down that 33 into an 8 times 30 and then an 8 times 3. And this is going to be something then we could probably do in our heads. So 8 times 3 is 24, which means 8 times 30 must be 240. We add that 0. So now I just have to add 240 plus 24. That gives me 264. So again, a lot easier to do it that way. I didn't have to take out a calculator. And quite frankly, this is how I multiply numbers in my head. So when some of you are at the board and you're asking me a question, this is how I'm breaking it down. I'm not counting by 33s 8 times, or I'm not counting by 8 33 times. I'm pretty much rounding this number to the closest tens so that I can do it. So kind of the same thing here. So 12 times 98. 98 is really close to 100. So kind of similar here. I'm going to multiply 12 times 100. And now since I went over by 2, I'm going to end up subtracting. And I went over by 2. So 100 is 2 more than 98. So I'm going to subtract whatever 12 times 2 is. Well, I know 12 times 100 is 1200. 12 times 2 is 24. So then I know I can subtract those, and I get 1176. I don't have a calculator with me right now. I'm just doing all these in my head because of how I'm breaking them down using distributive property. Okay, so here we're going to look at what each property is. So 7 plus 6, and 6 times 7 is the same thing as the commutative property. Okay, here I have 5 times A times B, and then 5 times A times B. So here we're multiplying A times B first. Here we're multiplying 5 and A first. So when we switch it around, that would be the associative property. Kind of the same thing here. Here it wants us to add 6 and 4 first, because that's what's in parentheses. Here it wants us to add 4 and 2 first. So no matter what, I'm going to get the same answer because I'm still adding 6 and 4 and 2, and 6 and 4 and 2. I'm just changing how I'm going to add them up. So again, this would be another associative. So I'm just changing how they associate. And then here I have 27 plus 3, and then back and forth, same thing, 3 plus 27. So that would be an example of the commutative property. Okay, here we have 10 times 2 plus 3, or we break it up and do 10 times 2 and 10 times 3. So this would be what we just talked about. This would be the distributive property. You're distributing that 10 to that 2, distributing that 10 to that 3. You end up with distributive property. Here, 5 plus m plus n, or 5 plus m plus n. So again, we're changing where those parentheses are. In the first set, it was 5 and m first. In the second equation, it was m and n first. So when we change the order of things, we're changing our associative property. Here it looks like we have a times b plus 2c, and here we have ba plus 2c. So we kind of got a little bit of both going on here. It's kind of the same thing backwards and forward. So I would say this one's commutative property, but I could see how some people might say associative property because we have AB and then we have BA. So that one could get a little tricky, just as long as you know it's not distributive. And then here we have 3x plus y plus z, and here we have 3x plus y plus z. So again, we're changing our parentheses and what we associate with. Here we're adding y plus z first. Here we're adding 3x plus y first. We're just changing how it associates. So that would be associative property. And then this is the next lesson on combining like terms, which it looks like the video is getting a little long right now. So I'm going to cut it short here and then make a new video for combining like terms.